So we're moving on with CO17, using relations to determine if an equation is a function. So a function is a special type, folks, girls, a function is a special type of relation. We talked about relations. There is any collection of ordered pairs. It can be a table, it can be a graph, whatever, but a function is a special type. And do we remember functions from pre-algebra? Anything coming to mind from that? You can't spell function without fun, so we know we're in for a good time today. But the definition of a function is a relation where every x value has exactly one corresponding y value. Every x value has exactly one corresponding y value. It doesn't make a lot of sense. This is kind of one of those definitions we're seeing. This kind of makes it better.
Explain it like birthdays.
Yeah, using birthdays.
One person can have like the same date.
No, this
or
is
like
so
multiple
confusing.
people can have the same date.
No, not this.
Yeah. So let's take a look at some of the examples. Okay. I've got two examples where both of these tables are functions. Both of these tables are not functions. And if you look at the difference between them, notice how in the function section, when x is 2, y is only 9. Right? It's the only y value that's paired up with the x value of 2. When x is 5, y is 7. When x is 10, y is 10. Or when x is 8, y is 10. When x is 4, y is 18. Okay? Every x value is exactly one corresponding y. Even though y repeats itself here, that's okay. Because when x is 8, y is only 10. When x is 8, y is nothing else. When x is 9, y is also 10. That's okay. Because when x is 9, y is nothing else. As opposed to these tables that are not functions, notice how when x is negative 2, y is two different things. When x is negative 2, y is both 7 and 10. That's the problem. That's what makes it not a function. Okay? Relating it to the birthday example that Tatum brought up here, it's like saying that every one of you has exactly one birthday. Right? There's one day that you truly celebrate as your birthday because that's the day that you were born.
That's not how you explain it.
That's like what a function is. Every person has exactly one birthday. Now, can you share a birthday with someone?
Yeah.
Okay?
With the same person.
That's okay, right? Two different people can have the same birthday. That happens. There's only 365 days in a year, 8 billion people. It's bound to happen, right? That's okay. However, can the same person have two different birthdays? No. Okay? So that's how that example relates to the function, not a function piece. Basically, if x repeats itself, it's not a function. Because that's saying that when x is negative 2, y is two different things. The same person cannot have two different birthdays. Not how it works. Okay? Yes, James. Just get it over with, please.
Unless you're born in
Can you sing the
February.
Pram song while we wait?
Can I sharpen mine?
Well, he sharpens his pencil. All of you just reflect. Whatever to mechanical pencils. Why don't we use those?
I was children right all of mine have
How many ties? Mr. Schultz, how many ties?
Oh, boy. 200 plus.
Yeah.
And you don't even pay for it.
All right. 3, 2, 1. You are quiet. Okay. Does that help clarify? Ellen, you had said that it was confusing. Does that help clarify? Okay, basically, if x repeats itself, it's not a function. Notice that in both of these tables here, x does not repeat. In both of these tables here, x does repeat. That's kind of the rule of thumb here. Okay, if x repeats itself, not a function. All right. So looking down at the homework section here, these first four tables, does x repeat itself when x is -1, 0, 1, or 5? No. Therefore, is it a function? Yes. Okay. Everybody, right? Every person has its own birthday. Even though 3 of them share a birthday, that's okay. Right? Y can repeat. X cannot. The next table here, does x repeat itself?
Yeah.
Is it a function?
No.
It is not. Okay? It is not. Evan, question.
For the bottom, is it the same as the top?
We're not there yet. Let's just save that. I got more to say about the graphs there. Okay? The third one, function, yay or nay. Raise your hand if yay, a function.
Yeah.
Raise your hand if nay, a function. It is yay. It is a function. And the reason why is, why would you ask, we're in the middle of teaching, he's across the room, why would that be an appropriate time for that question?
Now I want to know what happened.
Because you just derailed everything.
Not an appropriate question for the time.
Right. Don't all say.
No.
Now let's try a thought. I was about to reveal the ultimate math hack that would help you solve any math question forever. But now I forgot what it was. So we'll just last one. Function, yay or nay? Yay function? Nay function. It is not a function. Okay, and the reason why is because x repeats itself. Okay, if x repeats itself, it is not a function. Questions? Happy Tegan.
Can we write not a function and function instead of yes or no?
Sure. I've never had someone ask if they can write a longer answer before.
I just feel
Yes.
bad.
Yes, you may.
Wow.
Okay.
Mr. Schultz, that's kind of
So,
more reasonable.
how this applies now to the graphs, okay? When x repeats itself, the reason why it's not a function is because on the coordinate plane, what happens when there are two y values for a given x? For example, what would this relation look like if it were graphed on the coordinate plane?
Oh, just a bunch of one dot going to different.
Not quite.
Oh,
Not quite.
one-
You
I
go?
get, I know how, because an equation can't spit out different y values for the same x value.
True, it's part of it, right? If you plug in a value for x in an equation, you will get one y. You're not going to get two answers for it. That'd be chaos? Crazy chaos. Evelyn, what would this look like graphed on the corner plane?
It would just be a line.
It would be a line. What type of line? Let's just kind of test this here. Okay, so we have 1, 2, 3 for x, the only x we need, right? And then 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so 3, 6 would be about right here. 3, 7 right there. 3, 8 right there. 3, 9 right there. What type of line is that?
Straight.
Vertical. Okay. And if you think back to last year and you're talking about graphing, what do vertical lines not have?
Slope.
A slope, right? So relating this back to what you learned last year, a function is a relation with slope. Okay? If it's not a function, it doesn't have slope because what happens is x repeats itself. Take a look at this one here, right? At the x value of 2, y is both about positive 2 and about negative 2. Right? There's an ordered pair on here with an x value of 2 at positive 2 and another one at about negative 2. Is that a function? No. Because for the x value of 2, there are two different y's. 2 can't have a birthday at both positive 2 and negative 2. Right? Does this have slope?
Yes.
No, it doesn't. Okay, it does not. And that might be a poor example to use because these other three don't technically have slope either, even though they are functions. But we're going to get back to that function-slope relationship later. But basically, right, at the x value of 2, there are two different values for y, 2 and -2. For a graph, we have what's called the vertical line test, which if you can put a vertical line anywhere through a graph and it touches it in more than one place, it's not a function, because that means x repeats itself. If I put a vertical line through here, boom, boom, hits it twice. Not a function, because that means that at x equals 2, there are two different y's. Okay? This first one. Does the line cross over itself anywhere, like it does here? It curves back around, and I get that vertical line test hitting it in two places. Does it happen here? Or is it a smooth left to right movement? Smooth left to right movement. Any vertical line I put through here only touches the graph in one place, not two. Therefore, is it a function?
Yes.
Yes. Every x value has exactly one corresponding y. We talked about the second one, not a function. Okay. Third one, it's curvy, but is it a smooth left to right movement?
Yeah.
Does it fold over on itself anywhere? Any vertical line going to touch this in more than one place? No. Is it a function? Yes. Okay. The last one's a little tough to see. This going up and this going down, not perfectly vertical. It is gradually still expanding out. So this would be a function as well. It's a smooth left to right movement. Vertical lines only touch the graph in one place. So that would be a function as well.
Let's go.
It is hard to see. Every year, I tell myself I should put a different graph in there, and every year I forget. So I'll probably say the same thing next year.
So you just gave us all the answers and all that, right?
No, there's more at the bottom.
There's one question.
If we don't play the number game tomorrow, folks, it'll be the biggest travesty in the history of travesty.
Nice.
It would be a whoopsie.
It would be a major whoopsie. Your homework for tomorrow. The ordered pairs of a function are 4, 3, -2, 1, 3, 6, and 0, -5.
I already wrote it down. I'm already done.
Priya, what is an ordered pair that could be added to make the relation not a you gotta do this yourself. Not a function. Not a function. That's homework for tomorrow. All of you do it. You've got 6 quality minutes. That's how you math.
Don't forget to